Hello, it is currently 11:16. I just got back from a concert with my friend, which was super duper fun. It was my first time hearing this band, but it was so good. I'm still in my little fit. That's not that much of a fit. They were like folk folk music, so I want to be more folky, but I don't know. Anyways, I'm gonna show you like a clip of it in a second, but you need the context as to why this clip is so special. It's because I got a new phone. So I've had this phone for the longest time. It's not even gonna turn on now. I'm gonna show a picture of how smashed it was like here. The camera has been broken for over a year. Everything that I filmed on my YouTube, the reason that it looks so vintage, it's because my camera is literally smashed. And then the power button doesn't work. This is recent. This just happened. The volume button hasn't worked for months. And I didn't even smash it. I just had something heavy in my bag. And then for some reason it like messed it up. I don't know. I wasn't having issues with my phone for a long time and just recently got messed up. You can see this is what the back looked like. It's looked like this for probably years. This phone is 5 years old. You see, nobody can accuse me of overconsumption because I have had this phone for 5 years. No lie. And it looks insane. Anyway, so we got an upgrade. I got a refurbished one. 130 pounds, iPhone XR. You can see it still has the stuff from the store. Um, and the camera is so much nicer. So now I'm gonna show you a clip that I got from the show, which was so good. All right, it was so crisp. I was like, it was like a luxury. I was like, my phone is so crisp and clear, and like everything is so HD. But I've had a lot of questions that I want answered for my project that I really was like they were like weighing on my mind today. I was actually very immersed in the music. I've been feeling very immersed in my life recently. Like I've been like eating really slow and tasting everything and listening to the music, but I was like listening and it was like this is so good. I'm like so immersed and be like, but why does the recurrent excitation work that way? And I'd be like, okay, when we get home, I'd be like bopping like this, and then all of a sudden it'd be like, okay, but what do the weights mean? So it's actually been really weighing on my mind. So I just wanted to get some questions answered tonight. It's already pretty late and I have class in the morning, but not that early in the morning. So it's okay if I go to bed a bit late. I'm so tired, actually. Like I was so tired today because I wasn't actually expecting to have this concert tonight. So I had to wake up really early because my ID got like lost or something. No, somebody dropped my ID off, so I had to go get it. So I had to wake up like early, and then I went and I had classes, and then right after classes I had to rush back because I had a meeting, and then I had a long meeting, and then like I was like, my gosh. But it was actually energizing because I got to see one of my friends who is so cool and so nice, and he is the first person I ever met at my university. We met before, like we met literally through the university like Facebook group. And yeah, he's literally the first friend I ever made, and now he's in London for the year. So it's been kind of fun, even though I haven't gotten to see him as much as I want to. And it's kind of crazy because when I see people, I feel bad. Like I wish I had more exciting stuff to say sometimes. It sucks because this is actually in essence a very exciting thing that's happening, but it's like it cannot translate to anybody at all. So it's like it just again, I always seem like the most boring person ever who's just like completely stagnant and doing like nothing but work. And I'm like, I am doing nothing but work, but like it's very exciting that I'm doing nothing but work. You just like nobody can understand yet. So it's like it's a lot of like just I just seem really lame because it's like how do I explain this in a way that makes sense? I just have zero clue. It's like I don't know. Anyways, yeah, so I've just seemed like the most boring person in the world this year to pretty much everybody ever. So that's been really fun. Meanwhile, I'm like, this is the most immersive and exciting thing that's ever happening. It's like, yeah. But one of the questions that I had today was, so recurrent excitation hippocampal circuits, the way that it's explaining is that pyramidal neurons connect strongly to other pyramidal neurons, and then you get neuron A excites neuron B, and neuron B excites neuron C, and neuron C excites. Okay, so they're all recurrently connected. Isn't that the same exact thing as a Hopfield network already? Isn't that exactly what a Hopfield network already is in essence? Isn't this exactly isn't this exactly how a Hopfield network works? My friend and we were talking about our dating lives a bit, and I was telling him, I was like, I don't have one, but I justify it in multiple different ways. I was telling him, I don't know what's wrong with me that like nothing, I don't actually know how to put it. I don't know. Actually, I don't know. Actually, I don't know how to say it all. So it just doesn't work for me right now. Like, I feel like I'm an intense person, but then the other thing is that I feel like I evoke intensity in other people. That's why I've gotten in so many different intense like situations in life. I don't know if I evoke it, but I'm like, that's why I just stay away. I'm like, I catch feelings. That's my issue. But then I get scared. I get scared to like people because I'm like, no, like I catch feelings. So this is like a no situation. Because it's like it never I was telling him, I was like, actually, I had too many situationships in college. And I was like, I just can't do it. Like I just had to step away and not be in a situationship this year. And I've genuinely been so mentally at peace this year. I'm like, the peace of not having a situationship is so good. We were talking about how casual and situationship is different. I don't know, like, I don't know if there's something wrong with me. Like, I'm not a casual person. I'm just not a casual person at all. I don't know like how to put it. I clearly have such I don't think that I appear intense to other people. Maybe I seem like I have an intense inner world. I think that is very obvious if you interact with me that I have a very intense inner world. But I'm not outwardly like, super like, oh, like I'm a pretty quiet person, but I have a very intense inner world. And I just think that like when I interact with other people, it's like it's pretty crazy. I feel like I usually really like other people if I do like them and or they really 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 like me. I've never had a situation where I'm like I feel medium about this person and this person feels medium about me has never happened to me. So that's why I've just been avoiding it cuz I'm like it doesn't happen that way for me ever. I don't know. It just doesn't happen that way. So that's why I've just been staying away from everybody. I'm like, I just can't handle that intensity on top of this right now. I just can't. I can't do it. It's like it never goes like it's never just like a casual thing. It's always like this will be a memory that you will have forever. Like I don't know, like it's really bizarre, but I think because I'm intense, like I don't know actually. I actually have no idea. Maybe that's not true. I'm just like I don't know. I just feel like that's the situation. So I've just really been staying away because I'm like I got work to do. I don't have time to get really immersed in somebody else's life right now. It's like a lot to do. And then like also dating is such work. It's like, oh, you have to get on the apps and you have to talk to people and you have to do this and you have to do like it just doesn't freaking like no, it's so much work. Anyways, we were talking about that. We were just having a conversation about love lives. I was like, man, his is so much better than mine, bro. I need one. I just like obviously all of the intensity that I was pouring into liking people, I poured into this project now. So you can see how much I like when I like people, I like them a lot. That's why I stay away from people because I'm like, this is just like you're not gonna like this, or like it's not you're not gonna like this, but I'm like, I'm afraid. I'm afraid for myself, and like this is scary. Yeah, we were talking about attachment styles. I don't know. Yeah. Anyways, it just doesn't work that way for me. It doesn't. Okay, well, this is the confusing thing is that Hopfield networks are actually modeled after like after this type of memory anyways. So it's like I'm just trying to figure out like how do I make it go up and down if it's the same thing. Okay, well this is what's different. So I guess okay, so the inhibition is something. Okay, the inhibition is different. Without inhibition, the CA3 would just epileptically explode. That's really dramatic. So that's good to know. neuromodulators, that's what I'm gonna use anyways. So we already knew that. That's what I'm trying to put in there. I'm just trying to figure out like how do I include that? I think that this is actually, you know what's funny is that this is something serious. Like it's obviously doing something really serious, at least serious to me who suffered from this. So I'm like, to me, it's serious. But I think it's actually like, in a weird way, a really good beginner project. Like, actually, like it's really not a big thing depending on how I do it. Like, I actually think it's a good beginner project for the seriousness that I like that it has to me. It's really, I don't think, gonna be that hard to learn. Like it's just like it's I don't know. So I think it's actually a good thought exercise. So that's really convenient. Time dynamics, sharp wave ripples. Okay, let me get my pasta. So these are actually the differences are the inhibition, neuromodulation, oscillations, and plastic synapses. Well, I'm trying to put that on a Hopfield network, so I'm not going to answer all these questions tonight. I was just dying to know this. I was like, it looks like it's exactly the same with the way that ChatGPT was describing it. I was like, this literally is a Hopfield network. So I was like a little bit confused. Um, but it seems like the thing that's different is like just inhibition and stuff. I don't know. I'm not gonna think about that too much right now. I'm just gonna let that soak in. We'll see. And then the other question that I had, okay, this is yeah, this is my thing. So this is what I was learning the other day. I'm gonna open Canva again and we're gonna reopen that little one that I made on Canva. I'm always like, I can't sometimes tell if I need somebody equally as serious as me or if I need somebody like opposite. Like I need like a himbo. I don't know. I really have zero clue. Probably like a combination. I don't know. I'm like sometimes I think I'm too serious. I'm actually like a playful person. Like I like to play around, but I think I just get like really like in my world sometimes. I'm really introverted too. Like I like well actually I don't know. I actually really like spending time with people like a lot. Like it does make me feel good. I think I'm an ambivert overall. I like both, but I do really like to spend time like on my own a lot. And I think like I'm like I need someone who's like a little bit more on the extroverted side. I actually wrote down a list when I was like in middle school or something of like it was like dear future husband, like all this stuff, and it was like all the different things. This was yeah, and I actually wrote down that they were like I never can find this again, which is really sad, but I actually said they were gonna be more extroverted than me. So I think I do need an extrovert, whoever I date in the future. But anyways, what I was wondering today is why is n dot pattern t pattern the same thing as this mess of a thing in here? What is it? And what even is this? I thought it was supposed to be like weight I, weight J. Is there a different, is this like a symbol for weight? Because usually they put it with a W, and it's interesting that the mu is here again. See, now we know it's called mu. Oh, wait, here, look. Weight I, J. I thought there was a different one that had like a W and like a J in it. I don't know. Maybe I'm wrong. I'm a Virgo, but I'm constantly around Scorpios. This is what's crazy. My sister's a Scorpio. My mom's a Scorpio. My stepmom, also a Scorpio. My first love was a Scorpio. There's more. I'm just not thinking of them off the top of my head. But I have a lot of Scorpios in my life all the time. They're like inescapable. And I don't know. I feel like that gave my life like a heavy Scorpio energy. I have Scorpio fourth house, so that's the house of your home life. So Scorpio fourth house. I feel like I feel at home in intensity sometimes, and I'm trying to fix that. But also, I do feel very at home with Scorpios. I mean, literally, that's the house of family, and my family is Scorpios. But I'm a Virgo, but it's like it's like a human raised by wolves. I feel like I'm like that equivalent, but like a Virgo with like heavy Scorpio energy, even though I'm not Scorpio anything. Okay, so breaking down symbol and connecting it directly to my code. Okay, I already know the summation one. We know mu. Okay, this is she, C, or Xi. Those are two very different things. So I don't know how I'm gonna pronounce it. Xi doesn't even make sense. Xi, I'm gonna call it Xi, represents the pattern values. Anyway, that's really interesting. So all those symbols are just the numbers on the inside. Oh, so that's why it just multiplied by itself. And then it just multiplied by itself and then just over and over and over again. That's why the matrices in it are multiplying by themselves. And then it's going by like each level of the list. I don't know. I actually feel like going back to the Scorpio energy, I feel like I have had the most intense death and rebirth of anybody in my life. Literally, like the intensity of it all. I feel like of everybody I know, I have had the most intense death and rebirth energy ever. Like the transformation energy, the shadow energy, and like all of it. Like it's been really, really intense, actually. See, I'm like a secret Scorpio, but I don't have Scorpio placements anywhere, so I don't really know where that's coming from. Anyways, so it's basically for each pattern level, it's just multiplying like the first neuron. Wait, no. What's I again? Yeah, the first neuron times the second neuron. I think pattern T makes it like opposite itself. I might actually later draw this entire matrix out on paper so that I can like get an intuitive sense of it. What does N dot MP dot do? Actually, we don't even. Can I just look that up here? Okay, it just multiplies them together. Does one times this times two times blah blah blah. Okay, so you see it. Well, that seems very important for me to learn and to know. So that's cool. That actually just taught me like quite a bit. This isn't even as hard as I thought it was gonna be, which is really nice. And then I have other questions, but I might wait to ask those. So this is a full Hopfield rule, like how it's learning rule, how it's usually written. Why is it usually divided by n? And how does this translate into like a biological weight, I guess? Okay, so why is the Hopfield usually divided by n? So this prevents the weights from becoming too large because that it doesn't the more patterns you store, like if you store too many patterns, then it starts to get like way too big. So I think what I'm understanding is like this rule is applicable to basically anything that you could make. It doesn't really matter if it's like a massive network or a small one because this is going to be equivalent to like what's happening in one neuron, if that's right. I don't know if that's right, but theoretical results for a Hopfield network assume this normalization. Okay, I didn't understand that, but it's not important right now. So why many implementations omit it? In many small Python examples like yours, this is skipped because the sign activation ignores scale. The network still converges. Okay, if it's not that many neurons, it doesn't matter, which is why mine doesn't have it. And other things that I don't fully understand, like the network still converges. I don't know what that means yet, TBH, but it's not important to me immediately. You know what's funny is I think I'm still not fully wrapping my head around how these work, even though I'm now understanding like how it works on the inside, but I'm like I keep reading it. I think I just need like the refresh over and over again of like what is this doing again and like what I'm gonna stop now because I'm tired, like really tired, but this has been such a funny time because I'm so bothered by what I don't know at this point that it's like I just like I'm really like wanting to be immersed in it because I'm like now that I'm like the ball is rolling, I'm like I just want to understand every piece and like I want to understand it all. So it kind of just sticks with me throughout the day and like I just want to do more, but I'm really tired right now. So I think I'm gonna come back and then that'll like kind of guide the next set of questions. Okay, this is my least favorite lighting in my whole house. I hate the light in this kitchen. Like it always makes me look bad no matter what I do, but I actually had one more thing that I wanted to see. I really want to see a Hopfield network that's like one step above this, like not too complex, but like a step above this. And I want to see if everything that I learned kind of stands in the next version. Like where's like let's see if we can find like another Hopfield network. Because that one is probably the simplest one that I could find. Let's see if we can find like one step up. I don't know how to find that right now. The problem that I was running into is that a lot of the other ones, they actually give you, they kind of make it so that you're, well, this one might be good, but they make like a, like buttons and stuff. And like I don't really, I can't, I'm not gonna do that. I just want to see the code. Is it this? See, this one's getting annoying because you actually have to feed it the pictures and stuff. So it's just a little bit more, well, I guess we wanted a little bit more complex in the first place. This sounds so hard. I'm sorry, but like I'm like, this sounds so difficult. I don't know how to do this. And I have been learning the whole way through. So it's like I'm always saying that this is so hard, but it is so hard. And it's like I want to feel good about what I learned, and then there's like another thing to learn, which is really annoying. Yeah. Yeah, we're gonna do that tomorrow. But I think this will probably be a good one because it is a bit more complex and you're actually feeding it pictures. I haven't figured out yet how I'm gonna feed patterns to my Hopfield network. Am I gonna use images? Am I gonna use like just straight up numbers? I have no idea yet. So I think that'll be pretty interesting. It would actually be interesting to see the picture thing, but I don't know if that would be maybe appropriate for my model at all because I'm looking to see no, because I'm looking to see like stored patterns in terms of memory replay, so it's not equivalent at all. It wouldn't be biologically accurate or realistic at all. I think it's probably gonna, I don't actually know how the patterns are gonna be stored. I'll probably ask my supervisor that. I need to have another meeting with him, but I don't really know like what do I talk about in the next meeting? I have no idea. So I'm kind of like I'm just kind of on a little roll right now, so I don't know. Oh, wait a minute. So this is actually going to be a normal one and then you can upgrade it to make it this. You can upgrade it to make it like read the pictures. Oh, no, wait. I ran into this one before. This is my little this is what's annoying about this one is that if I'm remembering correctly, they give you like they give you activities or like they're like, okay, now you do this. And I'm like, I don't know how to do anything. So see, they're like, your code goes here. It's like, I don't know how to do the code. I just want you to do it so I can see it. Oh wait, let's see if I can like if I press code, what happens? Oh wait. Oh my gosh. Oh no, it still says your code goes here. Oh wait, but I think they still wrote everything. It's just for me to visualize it. What I want to do next is just compare these to each other and just figure out like what this does. It looks really different already. This one is British. In it, does this one have the same for loop kind of vibe? It looks so different. This one has energy. Why is there energy in it? Okay. Well, we're going to keep working with both of these. This one has a lot of different stuff. It has a noisy state. Is that the same thing as that noisy pattern in the other one? It has negative patterns. It has a lot of other stuff. It has, again, why does it have energy in it? All right. Well, one of them has energy implied, and another one doesn't. Kind of. There's like a lot of stuff happening. So that's pretty interesting that they're both exactly the same thing, but with the energy, it's a theoretical explanation and visualization, and without energy is just practical implementation. Will I have energy in mine? I do not know. Okay, now I'm for real done for the night because it's past midnight and I am pretty tired. Hello again. It's currently Friday, so it's 2 days later. I'm having such a good day. I made tomato soup from scratch for the first time, and I had a meeting and it got canceled, and that was my only like big thing of the day. So yeah, sometimes I've learned to be more intuitive with my body over time. I just let my body guide me a lot because it guides me to so many cool places when I actually just let it do its thing and just like follow its instructions. And felt like today was like a rest day. Like I let myself sleep in a lot and then I just woke up and made tomato soup and stuff. I that's like the key to my success personally. Obviously that's how I designed my entire research career that is not fully up and running, but it's like getting there is just like trusting my body because I trusted my body into a theory. and I trusted my body through this project. And it's really the secret to my success, I would say, is just learning to trust my body. And it was really healing for me as a survivor to be like, I will radically follow my body and radically listen to it, and that will be the key to my success. And it truly has been. I've just been feeling in like good energy recently. Also, very important update is that I found these really matrixy sunglasses that I thought I lost. I feel like it's really like perfect timing with me like having made a Matrix related video. Anyways, so I wasn't really gonna work on this today because I was kind of tired, but I started sitting with some of the other theories I had. I was like, these seem so right that like I need to finish this project. I was thinking about like the theories that I have been having on dissociative identity disorder. This project is important because it's going to, well, in theory, it will legitimize dissociation by a good amount if it can be replicated, you get me? So then that's a good start. And then hopefully I can do more stuff on dissociative disorders. I want to, like I said, go into a dissociative identity disorder, which has been very kind of tossed off to the side and just not really been cared about very much, I think, because of the stigma, but I believe in it. So yeah, I already have like my own theories of it and stuff. And I'm like, I just want to jump in, and I need this because I need to cite myself, you get me? And then I was like not wanting to do this because I felt like I was like, this is still gonna take so long, and I was really annoyed, but then I was like, you know what? I don't think I'm as far away as I think. Like, but I've been thinking that so long. That's why I was like, oh, I'm lazy, but we made quite good progress. Like I'm already learning about like how am I going to put recurrent excitation in here is the next big question, but I have a lot. Like I actually have quite a bit learned. Wait, really quick, I want to show what my cat's been doing today. She sat on the couch and she's just been further like every time I see her, she's a little bit deeper. Wait, can I show her? Do you see her? She's like she started up here, like up on top, and then she's like slowly been descending, like sinking into the couch between like the pillows. I think computational science as a career is going to keep me very entertained for a very long time because you kind of have to go, well, like from what I learned from speaking to my supervisor, who I also need to email because I haven't responded to. Anyways, but from what I like am gathering, it's like you have to go like small piece by small piece by small piece by small piece. Like you can't be doing like, I mean you can, but it's like you got to go like bit by bit by bit by bit. I'm like, oh my gosh, I'm like I'm gonna have to be like creating so many like mini little trails, you know? It's like, okay, this little piece, now this little piece, from this little piece. And my brain thinks in like really big things, I think. So it's like I don't know. It's like I already have like these like big like I was thinking about the theory like the dissociative identity stuff that I have, and I'm like, you have to make one on gamma synchrony, then you have to make one on like top down state. Like I was like, there's like you have to do like all these little pieces. I'm like, that's just gonna keep me really entertained for like a long time or like busy, you know? You know what's insane is that okay, my whole goal with this, because obviously I started this paper before I went into like my program at all, my master's program. So my goal was to publish this, and it's still my goal. I think my name might end up being the only one on the top. My supervisor told me about Hopfield networks, but he's not like doing any like he's just being my supervisor. So I expected that at some point in time I would like accumulate a second person or something. And it's kind of right now seeming like my name is going to be the only name on this paper, and then maybe in the acknowledgments I'll acknowledge my supervisor. So that's a little bit insane because it's like what? But granted, that took me extensive amounts of like time and work, so that's fine. Um, we're just gonna go back into Hopfield networks right now. So where I basically was in this last clip was energy. I think what'll really help me is just keep looking at a bunch of Hopfield networks a little bit and kind of keep seeing like what's up, what's the vibe. So here's like, okay, we're gonna actually start a new document. I have a massive paper due in 10 days too, and like I need to get started on that today. Wait, also while that's loading, not that anyone asked, but I also found these really cool cups today, which is perfect timing because I set up like a little tea station because I've been like crazy dehydrated and I keep forgetting to drink water. but I was out walking and I found these really cool cups that somebody just left for like anybody to grab. And I thought they were so cool. So I took them. I've been trying to remind myself to drink water. I've been reading in the last few months about how your brain takes up so much energy. Like it takes up a lot of the calories that you eat go to your brain, and just like a lot of resources actually go to your brain. And I was thinking, because I started stress eating a lot through this project, but I would just get hunger cues more. And I was thinking about how much effort it took to learn all this in a year and how much learning I did this year. Like I covered so much ground learning wise. I learned chemicals that I'd never learned before. I learned like computational neuroscience stuff. I learned Python. I learned like, and then I was doing my master's program and my job, and like everything was like so much learning. And I'd crave like sugar a lot, and I craved carbs. And I read that apparently your brain uses a lot of those, like it needs a lot of sugar. So I was like, I do think it's stress a little bit, but I also think that I'm just like really, really using my brain a lot this year. And I was reminding myself that like I have to fuel myself more. And also with water, because I was like, I think part of the reason I kept getting hungry is also because I'm thirsty. Do you know how sometimes when you're thirsty, it's like you feel hungry? So I've been trying to I'm so bad. I've been so bad at drinking water this year. So I've been trying to make sure to drink my water now. Rules? Question mark? Okay, so these are going to be our rules. Obviously, this one, it seems like every single one of them uses this. So, oh wait. I'm going to take a leap of faith and just assume that probably I'm going to use the same exact rule. Is that like just all Hopfield networks use that rule, I think? I'm assuming, so I might take a picture of it. Where is it? You know what I'm going to ask next? I want to find that rule in other computational models and see how they basically did it. Again, I'm going to be using Claude Code, but I still need to understand this. So it's not like I can just be like, okay, Claude Code, do everything, because then I won't know what to fix and what's going wrong and like, stuff. So that's why. I'm looking for the one that's like 1N. I went to Finsbury Park like a few days ago. I love Finsbury Park. That's an unpopular opinion, I think, because I talked to my flatmates and like they definitely didn't like Finsbury Park. Okay, that's where I used to live. I used to live in Finsbury Park. Like I don't know, I moved out like last year. Okay, but I used to live in Finsbury Park, and I'm super. Maybe it's an unpopular opinion, but I just really love the vibe of Finsbury Park. There's it smells like incense. There's so many cute little markets and stuff. I love it. Like I actually it just gives me a good vibe. Again, like it's so funny because I don't think the average Londoner thinks that per se, but I actually like it. Sorry. Anyways, and like I used to eat so healthy when I lived in Finsbury Park because there's so many like international markets and stuff and like butchers, like real butchers. Like I went up there. I feel so replenished actually. That's why I feel so good today. Is that yesterday I went to Finsbury Park. I got what did I get? I got my little tea thing. Like, let me show it. I was wanting one of these where you like press it on the top. I was like, where you can get this really cheap? Finsbury Park. So I went to Finsbury Park. I got this thing for £17 and it's really good. And I got a I went the grocery store that I used to go to is so good and it makes me really really sad to not have it around me because in my area now it's like very very British, like it's not international in the same way, and it's just like a Sainsbury's and like stuff like that, like just like a normal grocery store, and they don't have the same selection. So I think that's partly the other reason I've been eating so bad here is like it's so much easier to just eat randomness. But I went up there and I got like a big bag of okra because I love okra. Like I filled a big bag and I already like cooked it, meal prepped it. I got yuca, like cassava, I think is the other name for it. I make like soup. I got like so much good, like I got like black quinoa, red quinoa, like all that stuff that they sell like up in Finsbury Park. I got it. And then I got my brows threaded for £5. I hadn't gone to get my brows threaded in so long. And when I tell you I don't feel like I look good without my brows done, like it actually genuinely impacts my self-esteem when my brows aren't done. And it's so cheap up there and they do it fine. And then it's like down here, I'm like, where do I walked like a very large span around where I live, and everybody does like get like brows waxed. And I don't want to get my brows waxed. I've never done it, but I just don't want to do that. I like getting them threaded, which is why I just looked crazy for like the last few months. And so I genuinely left feeling like a whole new woman. I was like, I got my veggies, I got my brows threaded, like I got everything. That's why I love Finsbury Park. It's so good. And then from there you can walk to like Camden. You can go to Highbury and Islington. Like it's such a good area. I really personally like it, but it's not everybody's cup of tea because it can be a little bit dangerous, I think. Granted, I used to be taking the bus back from my job and I'd get back home like 2:30 in the morning, 3, and it does feel really shady at that point. And it can be really shady up there, but I miss like I would it just feels more homey and it just feels so much more Londony than where I am right now. Like this area, it's just so like in the city. I like Finsbury Park a lot. There's areas like that around here where I am. There's areas like Finsbury Park all over London, but it's just not like I have to take like a bus and like all this kind of stuff. So it's like I never end up doing it. Whereas Finsbury Park, I just leave my house and like 24-hour grocery store. Here, everything is closed so early. It's really annoying. Like I went out the other day on a Monday, like a Monday night. I want to just get some food. Like I was like, I'm really not in the mood to cook. I'll like splurge. I went out to eat. It was literally like maybe 5:30 p.m. Everything was closed. It was like restaurant closed, 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 closed. Everything was closed. Finally, I settled on one place that was open, which was because I only had cash at that point too, so it was like trying to it was a massive challenge. And then I finally found one pub that let me pay with cash and was open. So it was really annoying. Finsbury Park, like stuff is close. You can get stuff pretty late, so I just miss it. But again, unpopular opinion. But anyways, yeah. So the full Hopfield rule is usually written like this. So I'm assuming that's what mine is gonna be like. I have a lot of different questions, like how many neurons will I have? I think mine was too small. The first one I looked at was too small to have that. I don't even know how the other one I was looking at, like how do the neurons work for that? Where are the neurons and how do they work? I want to look like at a biologically a realistic one. Is that a thing? I'm just a bit confused. Like, I actually have questions. These might go to my supervisor. I don't think that's probably a thing. Like, biologically realistic Hopfield network doesn't, like, that's not like a thing, I think. But I'm just confused as to how to get, like, what are the neurons? I don't need to run it that much. I just need the code. Okay, so this is like so you train it. Like, let's write all this down actually. There's like a training period, I guess, where you like teach it a pattern. Then you input something like messy. This is maybe I'm wrong, but I feel like Hopfield networks are kind of like how bottom up and top down processing works too, because it's like, well, yeah, it is, because that was literally the whole point of Surfing Uncertainty, which is the first book I read. So this is exactly, yeah. Basically, like you get your predictions that your brain is making are like important to how you process stuff that's coming in. And then, yeah, you see the output data is like how it's understanding the image. These don't even look like they're doing like a perfect job, TBH. Okay, I got really confused because I was reading it like this, like train data. You trained it with this, and then it's like output this, input data. And I was like, what? That makes more sense. That's funny that you could put in a man with sunglasses and it would still know that it's like it's not supposed to have sunglasses. That really shows you how top-down processing works too. Like even though it takes like this like little messy bit, it still sees it as this. This is kind of random, but you know who would like this whole thing? Like if you were alive today, would be Plato. You know, it's like the what's it called? It's been a long time since I took a philosophy class. Like I took one philosophy class freshman year of college. His like ideal, like what's it called? Like the ideal form, platonic ideal. I don't know. That like there's an ideal version of every single thing that you're comparing every other thing to. That's kind of the same concept in a weird way. That like in your head there is like a perfect tree or like a perfect cat, and then everything else is kind of like, you know, there's like, even though it's imperfect, like you're still, I don't know, I haven't learned this in a while. You're still comparing it to like the platonic ideal. So I kind of feel like you're giving your brain like a platonic ideal of like a thing, and then it's learning to create that over time, and it's like always comparing it. It's kind of interesting. this is like the platonic ideal of a man, and then it's like you get this and it's like this is just not it. And then it's like no, this is the perfect one. I have corrected it. And then that goes into Carl Jung's ideas, who I haven't even read, who talks about what like the archetypes and collective archetypes and stuff. So they're kind of right in a way, because I mean, it is kind of like that your brain works. It's got these like little cluster sets of information that it's like this is how it is, and then it's like, yeah, I don't know. I need to actually read Carl Jung. My mom gave me some Carl Jung books for Christmas like 2 years ago, and I keep meaning to get around to it, and I just haven't read Carl Jung. But I will say, if you don't know, he's very popular in Brazil for some reason, I think. I don't know. People like Carl Jung. Or maybe that's just my mom. But I think she told me that. Okay, so that was completely unproductive. Where is the code for this? I don't know. I'm sorry, like, it makes me feel so stupid because I genuinely don't know how to find the code. There's like 1,000 different documents. What is this? Network PY. So I think this is actually it. This is the Hopfield network. Okay, yeah, so look, so you're training the weights here, initializing the weights. So we can already see that they're doing the same thing as the other one. Let's pull up the other one. So yeah, so here we have the same for loop. So you're already like we're already starting to see the similarities actually, because here's like the other one. There was that weight equals NP0's pattern size, pattern size. I think that that's the same exact thing as this. W equals NP0's self dot number neuron, self dot number neuron. So we'll need to see like why is it pattern size instead. But here's a mysterious one. What is RHO? What is that? I think this might be, I don't know actually. We'll have to see what that is. And then here's the same rule. Like let's try to find it again. This is the one we were looking at. So we have very similar things going on here, even though this one does more. So again, so weights equals MP0, we have it again. This one is just W equal MP0s, but I think it's the same exact thing. And then this one is for pattern in patterns, pattern equals whatever, whatever. This one, it looks like it's the same. This looks like the rule. It does say like the Hebbian rule. So for I, so this is for pattern and pattern, I'm assuming. For I in TQDM, what is TQDM? Okay, TQDM is something they imported. Range, number data. Okay, I'm seeing there's like a lot more complexity going on here. T equals train data, and then weights equals, so it's pretty much going on, like the same thing is going on. Let's duplicate this. So for I in TQDM, that's like this. I think that's just the summation. T, so we have the weights here equals this. This is what a weight is here. And then I'm going to ask what RHO is. Like, I'm going to ask ChatGPT in like a second. What is TQDM? A progress bar. Why is there a progress bar in this? I don't know. I'll ask that in a second. Then we have this part. So this W plus equals, let's see, what was it up here? Nothing. Oh wait, this is just like the adding it up and over and over again. Actually, that was just like also part of it. This right here is equivalent to this. So instead of n point dot pattern point t equals pattern, we have this. Now let's double check that with ChatGPT and see if we got that right. Let's go ahead and ask it what row is, because that's the thing that I have never heard of before. It's funny how this one uses the MP, but like I think it is because I think it's adding stuff together, like it's adding like the first piece and the second piece, but I don't know. Also, where is train data? Is that a that's something that you're inserting here, maybe? Like, where is it coming from? What's the source? Is it coming from like a, yeah, I think it is like just something that you like put in, but I guess maybe it's the data that you put in. I don't know. What I find pretty interesting is that in this one, they're multiplying by each other. This one is subtracting. Why is it subtracting? So let's see now. I'm gonna drink my little tea. I'm gonna drink more tea while we're at it. Let's stay hydrated. Short answer, so similar vibe, not exactly the same. Okay, so this is a different rule. So this part right here produces the same type of vectors. Let's look at this one again. So I guess it's this part at the end that produces the vectors, is the MP dot pattern T pattern part. I don't know why I said vector, I mean matrix. Why is T equals train data minus RHOU? So instead of using the pattern directly, the code subtracts the mean activity. So you see the rule is different. So it takes like that same information. It's the same rule. Wait, let's go back. Let's go back to the rule. You see the same rule. It looks very, very similar. This I'm telling you like I know, but I'm telling you from what ChatGPT is saying. But it just subtracts the mean. That's it. Like that's kind of the difference. It's a centered Hebbian rule. And rho, what is that? The average neuron activity across the data set. That's pretty interesting. So I guess maybe that makes for a more precise thing or something. So rho is getting the average, and then here it's subtracting the average across like both parts. This is so confusing as someone who hasn't taken calculus right here. Why are there two summations at the same time? Are they multiplied by each other? But like there's nothing in here. Are you just like it's the summation of the summation? And that's so like how big of a number must that be? I don't know how that works, but I'm not going to question it right now. I have taken calculus. It's just been a really long time. If patterns contain mostly zeros and ones, P's might be neurons are active 30% of the time. Okay, so it's the mean of how much the neuron was working. So why subtract the mean? Because some data sets are biased. So neurons are mostly one, which creates a strong bias in weights. Subtracting the My Wi-Fi decided to like not work for some reason. Let's try that again. This has just felt like a wall of learning, and I'm like, this is taking forever. And it's like there's always like another thing, but I actually do think I'm getting close to done now, right? Like, right? Or am I not? What I wanted to ask is about biases, and because of my Wi-Fi, I deleted my question, which is really annoying. I was asking what is a bias? Like what I forget there's like a specific computational neuroscience definition of like what is a bias and why is it an issue? I want to know how would it impact the image if you didn't remove the bias. Bias means that neurons are often in one state more than in another, which I guess is pretty intuitive, but for some reason I just needed to ask that. There's a lot of questions happening here. There's a lot of questions happening. If neurons are mostly one, then 1 times 1 is 1. So many. Oh, okay. So I think like once you start multiplying the stuff together, if something is really like skewed one way, then everything is going to go that way because like you're multiplying everything like that. I don't know, something like that. I'm going to stop it for a while after this because this is like, I just want to soak this all in because it's kind of a lot. It's not a lot of information, but like, I want to wrap my head around this. Why subtracting P fixes it? So it removes the average activity. So the networks deviate from the. I'm just so confused because I'm like, this is all happening so naturally. How? How is it naturally happening when you're the one in charge and you built it and you're putting stuff in? I don't know. I think I'm just like I need to understand like the deeper part more. The average activity. So the network learns which neurons deviate from the average together instead of which neurons are usually on. Because you want there to be negative space? Is that why? I don't know. I don't understand. One other question that I have is like, these are all neurons. I guess in an image, it's like, it's kind of a little bit, okay, this is kind of like when the place cells are happening, and then it's like certain neurons get reactivated, and then from that, the brain is like knowing what a place is. I think the image is throwing me off a little bit, where usually what happens in a brain is like rats, they'll be like walking around and then like certain cells are like getting triggered while they're walking around. And then at night when they're sleeping, your brain replays the same one. We've learned this in like many different classes. Like we learned this a lot in my program over and over again in like different contexts, but we learned about play cells a lot. And then we learned about how actually this is pretty interesting. When the rats like at night, let me see like if I can find the exact paper. At night, they can like if you play like a sound while the rat is walking around, at night, if you play like the same sound, you can see the rat's dreams in essence, and you can kind of see that the rat is dreaming about the same place, which is really creepy and weird. It's not creepy, it's just like really interesting and bizarre. So you can actually see, like, because the rats will replay the same cells at night, so you can kind of see that they're dreaming about that, like those patterns are being activated and they're dreaming about that same location, which is so crazy. So these are basically, it's kind of the same thing happening, which makes it much more intuitive for me because that's more how I'm looking at it for my own project. But like, it's like which like place cells are getting reactivated again. But for this, they're looking at images, so it's a little bit less intuitive because I'm like, I thought this was an image, but now it's a neuron. But that made it make some more sense, I think. I'm just trying to wrap my head around this for like my project too. I'm curious to like, I think I also haven't wrapped my head around how this is gonna, what am I gonna learn in my project? And how is this gonna go in my project? I don't know yet. I'm still trying to figure out. There's like stuff to think about for that too, and how I'm gonna set it up. There's just always something else to think about. It's really annoying. Every time I think I've got it, it's like there's more to do, and it's really irritating. But why subtracting p fixes it? You learn like the actual structure and not just like a bunch of jumbled mess, essentially. And then intuitive analogy. I'm still not sure why the mean, like how does that mean work? I haven't like wrapped my head around it yet, but we'll come back to that. Why the classic Hopfield rule doesn't usually need this. So if you use -1 and +1, they're naturally balanced. So they create ones and -1s and stuff. But so why did they include it? Like, why is there's not a normal Hopfield rule? I think it's doing the same thing as every other Hopfield network I've seen. Like, it's just bringing pictures up. But let's double check that. I'm also going to ask if I'm looking at, I'm imagining that I'd be changing the plasticity rule, but that might not be true. I just asked if I'm looking at acetylcholine and recurrent excitation and how it impacts memory, how memories are replayed with the Hopfield network, would I most likely be changing that plasticity rule too? So this one, an image reconstruction one might be different because patterns are images rather than random vectors. So I guess it's like you want to see like the black and white negative space, I guess, of the image maybe. So yeah, that's why I was getting confused. So it's a pixel instead of a neuron. So that's why it's really important that the noise that's like really crisp. Data may be 0 and 1 instead of plus and -1 because 0 is black. Why don't they just make -1 black and 1 white? I don't know, but it's not my problem right now. Processing and normalization. I don't want to get plus. I do, but I don't right now because I don't have money. Okay, data may be 0 and 1 instead of plus and -1. So pre-processing and normalization, images often include mean subtraction, scaling, and sparsity constraints, which are not in the original Hopfield paper. So, and images, like there's so many pixels that there could be like thousands of neurons. So that's all the reasons why, which makes sense. And then if I'm doing ACH and recurrent excitation, this is what it's saying I could do. So I could modify the network dynamics that would be more common. So not the learning rule, but how the neurons update. So represents modulation of recurrent excitation. I have more questions about that. So I have no idea what that means yet. I'm going to ask more. Or I could modify the plasticity rule. So I could also change the learning itself. So for example, okay, so there's a lot of different things that I could do. It would usually be the network dynamics, not the plasticity rule. The reason I was asking that, I don't know why I thought that for some reason. I think it's because I thought that I was supposed to change the weights. I thought I was supposed to change the weight, so I thought that was why, like in the plasticity rule, but I guess I got that wrong, or like I just didn't understand fully. So that it has to do with how memories are recalled, not about how they're stored. So I don't know. Actually, I want to think a little bit more about acetylcholine. Right now, I'm just really in like Hopfield network mode and learning that. But okay, I'll probably be back. I'll probably be back later today for a bit still, and then this video will probably be edited from that point because I think it's starting to get about the length that I usually make my videos. If I could make one that's 6 hours long, I would, but I just feel like it's like a little much. So I'll just be back in a bit. Okay, I'm back. I'm just looking here at my document. So I'm really guessing that this rule is probably it's going to be something adjacent to this. So because I don't think I need to change anything related to the weights. I'm probably just going to have really typical patterns. I'm not going to have images because I'm trying to like let me write that down actually. Just to remind myself, like just to give myself that vision of what I'm looking for here. So I don't think that anything is going to change here. This probably stays the same from what I'm understanding. I keep trying to figure out how I'm gonna run the actual experiment part and like what do I want that to look like? One thing I was recently thinking was I could make that acetylcholine function and then I could have one with like high, medium, and low, or like none. This is kind of a tricky part. I don't really know how to do this part that well. Like, what does my experiment look like? I was gonna do one that's like high arousal and one that's medium arousal. But what my supervisor had suggested for me to do was just to run, because I had like all these different thoughts on how this actually happened. But he suggested that I run one that's just that recurrent excitation. So I thought like just high. I need to figure out how to get acetylcholine into this. And we're gonna just think really quickly about how acetylcholine works again. So when it's high, you're getting less recurrent excitation. And then at like the lowest you get like if there's none or if it's like really low, you get high recurrent excitation. Things that don't matter as much to me is just like pattern separation. I don't think I'm gonna have the dentate gyres or whatever they're called. Obviously not. So I don't think that matters anyways because it's a hopfield network. But this is why I was getting confused and I thought it was supposed to be a plasticity rule because it says adjust recurrent weight influence during recall. I honestly don't think that ChatGPT, like, it made this mistake when I was making my stuff over the summer too. And it just, this is something that I keeps irking me with it, is that it keeps making acetylcholine, it would have zero to do with the recall because it's not going to be up at all during the recall because there would be no, well, I guess in the model, but I'm like, before what it was doing something really annoying. Like it was like encoding the sharp wave ripples or something. So it keeps trying to basically put the acetylcholine during the recall place, and I'm like, it's not up at all. So that's really annoying. I think I understand what it's saying, but even so, like maybe I'm just not getting what it's trying to say. But it did make that mistake a lot over the summer, so I'm gonna try not to listen to it too much here because that's like I don't know why it kept like getting that little bit wrong, but it was just like not understanding that. So I have to have a think about it myself. So what I understood it to be is like the potential that these neurons have to like spontaneously start to kind of like replay. Is that the same thing as pattern completion? That's one question. I'm I don't know actually. Before I actually see that, I might go back to where it was actually explaining recurrent excitation. If I could make it like in my head, how it should be is that it should be like a knob, like a knob where I'm like click, 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 click. And it's like if it's going up, it's like recurrent excitation is down, and if it's like click, 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 it's like there's none. But it's kind of hard to. It's not really possible to. I think hopfield networks are a little bit too stagnant for that idea. Like it would have to have like a separate code. Like I'm just gonna make one up like right now. Like not I can't write it or anything yet, but I've been surprising myself honestly. Maybe I'll have some idea of how to by the end because I didn't even expect myself to be able to do any of this. So I have kind of been surprising myself. We're gonna open Jupyter Lab. Okay, so this is actually the exact same one. This is the code. So I'm just gonna look at it and like you see, oh wait, no, this is the evil one. This is the evil one that ChatGPT wrote that I'm not trusting ChatGPT anymore. Not anymore, but I only trust ChatGPT to ask questions, like to have my questions answered. It's pretty good at that, but when it comes to certain things, I'm like, I don't trust you 100% to understand this and that. So, okay, let's try to figure out which place it should go in. So, okay, these everything here is going to be staying the same. This is where it gets to comprehend the pattern. It's at this point that the acetylcholine would be up. Okay, so this is when like you're assuming like I'm gonna write basically what these things should be. This right here, it's like this is the past memory. Okay, this is like what you learned before. This noisy pattern should be like the trauma memory that I'm basically having it learn. Okay, it's learning a trauma memory, except in this situation. Okay, this is just learning, just normal learning. This is the thing, is this trauma impact this? And do I there's actually a lot more going on in this entire area that has to do with trauma. So that's the really frustrating thing is like if I could do the most complicated one in history, it would have like, the CA1 isn't doing, it's not making LTP as much and it's doing this and that. And it's like in an ideal world, I could show how there's so many different things going on that are causing amnesia, but I can only really focus on one thing. So I would think, unless I want to try to run one single one that has a different kind of learning. I don't know. Like it definitely trauma changes the way that you also learn, but that's probably just too far outside the scope of what I'm trying to do. Wait, actually, this is when it's learning, right? No, is this replay? That's actually like a good thing to learn here. What's the thing that's most equivalent to like, okay, because like the memory is happening and you're learning, it would actually kind of be like, well, these are past memories. These are past memories. So these are like, okay, that was like I went to the store yesterday. This is like now I'm at the store and somebody's got a gun out. That's like what it's trying like this is what it actually would kind of come down to like this a little bit, I think, because that's the kind of confusing part is that I think by the time you're like, actually, where is it being incorporated? Okay, let's walk through it. Here you're like, okay, I went to the store yesterday. Here you're like, I went to the store and somebody pulled out a gun. Like, oh my God, okay. And like now you have to like connect it to other stuff. I think this is actually showing me what I'm not like getting about hopfield networks. Isn't acetylcholine kind of changing the biases or something? Like you would think, right? Let's briefly write down what acetylcholine is doing. Acetylcholine. Acetylcholine is making you less likely to replay memories while you're learning and like connect to stored patterns. See, when I was first thinking this, I thought that it would go like here somewhere in like the iterations because it's changing how I guess this is kind of like asking, okay, what's happening like if you try to recall a memory, I don't know, recall and replay are different things. If you try to bring up stored patterns while ACH is high, what happens? And so I guess it is impacting this still. It would be something like if acetylcholine is high, it can't like bring up the patterns. I'm just trying to figure out like what's missing here. Let's ask like how do what's the difference between us just like the stored patterns and like recurrent excitation? Is that the same thing? Okay, I didn't think it was the same thing. One is a network mechanism, the other is a computational function. Okay, but like, is it the same thing? Recurrent excitation refers to a network structure where neurons excite each other through feedback. Okay, this is what's really urgent. They're the same. It's the same thing as like a Hopfield network. So that's what's really annoying me. Is like, yeah, that is how it works, but that's exactly how a Hopfield network is built. So it's kind of like if like putting the ACH up is kind of unhopfielding the network. That's not the right way to put it, but it's like if you, I don't know, it's like now nothing can connect, and it's like a non-hopfield network. I don't know. It's like the less ACH, the less ACH, the more hopfield the network. The more ACH, the less hopfield the network. Okay, anyways, in brain circuits such as the hippocampus, there's something like missing here though, because acetylcholine makes this less. So it's like that's what's really irking me right now. I'm like, okay, yeah, but like obviously it goes up and down, and like what is it then? God, I'm getting driven insane right now. So it's like unhopfielding the freaking hopfield network. I'm just like going insane. Like this is what I was saying in the beginning. I'm like, it's the same thing. It's just like, what if my question is basically, how would a Hopfield network work if it was completely not a Hopfield network at all for some period of time, which is really annoying. And it's like, okay, yeah, but it's not understanding my, it is understanding my question. I'm not like, I don't know. Okay, so this is what I mean. Recurrent excitation is what enables pattern completion. So all you need to do is make it so that none of this works for some brief period of time, and then there you go. This is like the anti-Hopfield network, which is kind of weird. How do like it's like for some period of time, none of this is able to work. So okay, this is my question now. Then, where's the Hopfield of the network? Like where is the how does like what about the code makes the neurons all connected as a Hopfield network like should be? Tell me from the first code I gave you. Because like all I need to do is like completely undo that part. It's like when acetylcholine is high, none of that works. Like everything is like disconnected. If it's medium, like it kind of works. It's like I'm completely unraveling the whole thing, which is really funny. Okay, so the way the matrix network is constructed and used. So, okay, so for pattern and patterns, the important operation is end. Okay. So, see, I knew it was somewhere in the rule. I was like, it's in that. This is why you trust your logic and you don't trust ChatGPT, okay? It's not that ChatGPT is completely wrong, but ChatGPT, like, you need to rely on your intuition and your know-how. Because you see how I kept asking, I said, is it in the weight? Is it in the weight? Is it in the part that said weight? And ChatGPT was like, no, it's in the other thing. It's like, bro, it's there that I'm trying to get something unraveled. Like that's where I'm looking for. And you see how the other thing that it didn't even work. That's why you don't like it's a good tool, but don't use it for everything. Not for stuff like this that matters. The update rule uses all connections in your retrieval code. So it's this dot thing. This NP dot thing is like my thing I need to undo. This project has tested my logic skills so much. I honestly didn't think that I could produce like such intense logical anything. Like it is like the most intense logic exercise ever. It's crazy. And I'm just like, okay, now think deeply about each and every piece. And it's like, oh my God. Like you need to unhop the Hopfield network. It's like, no. So something here needs to go off when the recurrent excitation is up, right? Because it's like they're not as connected. Is that correct? I think I'm gonna let that sit now, and I think this might be the end of this video. You see, I said it's in the waist. I said it's in the waist. There's something there that needs to be thrown off. Let me just, see, now I don't trust ChatGPT, but I'm gonna ask. No. Okay, no, let's think more deeply about this. If recurrent excitation is low, does that mean the neurons are less connected? It's Friday the 13th today, isn't it? That's so creepy. That's why, oh my gosh, last night at like midnight, I got in the creepiest mood. Like I was watching creepy videos. So The connections are stored in the I don't know if I have like I need to sit with it. I need to let it soak in. I need to let it soak in that I need to unhopfield the hopfield network. And how do I do that? And where do I do that? And like what does that mean? Um, and so this might be something that I'm gonna read in the next video. What recurrent excitation actually refers to. Okay, yes, you told me that a million times, and I know this. So yes, you've told me a million times. It doesn't remove it, it modulates the transmission. So it suppresses them. Okay, but I'm just trying to figure out like how does see I said knob. I know this all, but I'm just trying to figure out like how does this translate into the freaking network? I don't know because I'm getting annoyed. So this should probably be suppressing something. Suppressing something, but I don't know how that works. Okay, so that's our notes for next time. Okay, so high acetylcholine, everyone speaks quietly. Low acetylcholine, everyone reinforces each other. The group can quickly agree on a familiar idea. So does it like lessen the weights? Does it lessen the weights and make them weaker for each neuron? Question mark. Okay, I'm addicted to this in a way, but I also just want to let it sit because I've just learned again, like this is my big thing, like don't work for like 10 hours because you're just gonna sit there going in circles and getting annoyed. Whereas like if I work for like, I don't know, especially if I'm doing something really complex, if I do like 30 minutes of learning and then I step away for like a while, come back like 2 hours later, my brain is fresher and I can get more done in a day doing like three 30-minute sessions or three 45-minute sessions than I can get done if I like work for like, I'm like, no, you need to understand it today. It's like, no, you see, you gotta let it all consolidate, take a while, like watch a movie, whatever, then like come back. It's better than to be like, I'm gonna do 10 hours of this and by the end I'll understand it all. Like it doesn't work as well. So I think I'm gonna stop like this whole video today and like that's I think gonna be it for today because I just really like I think if I sleep on this, I'll understand it better. But that was actually really productive thoughts for the last few days and like it's really seeming like I'm getting somewhere. It'll be kind of fun to show this to my supervisor next time I see him and just be like, okay, like this is what I'm doing. Yeah. Anyways, time to unhopfield the network. All right, so that's basically it for today. Kind of tired, kind of feeling like it's time to just entertain myself for the night. I actually already watched Annie. Annie is such a good movie. I love every version of Annie. I love Annie, like redhead Annie. I love the recent Annie, the like race bended version of Annie for some reason, but it's so good. And I just love like all the Annie. I don't know, like I've really been into Annie recently. So yes, I watched Annie today. And yeah, I'll probably go, I don't know how I'm gonna entertain myself for the rest of the night. Like I feel kind of unsettled, but I just don't think I'm gonna get it out of myself tonight. And I kind of just wanna let it soak. But yeah, at least now like I feel like the task is becoming increasingly more like clearer and I understand how all this works better as time goes along. So that's really exciting. And yeah, bye bye.